Hello guys, this is Anirudh and today is our first video in the Finance with Python series. Today we're going to be looking at a brief introduction to Python, why Python is used in finance, and how to download Python on your PC. So Python is a high-level programming language that is widely used in various fields like data science, web development, artificial intelligence. The list just goes on and on. So, looking at the history of Python, it was invented in Netherlands in the early 1990s by a man named Guido van Rossum. So, he worked at Google from 2005 to 2012, and that is where a major chunk of Python was developed, and Google adopted it right from the beginning. So, let's see why Python is so popular. It's popular because of its vast array of libraries that it provides. So you can see Pandas, NumPy, scikit-learn, matplotlib, and seaborn. So these are very popular libraries that is primarily used for Pandas and NumPy for data analysis, data cleaning, getting the right data so that you can analyze the data and get some visual insights from it. So matplotlib and seaborn are data visualization tools. So after you do the data analysis, if you want to visually see some insights from it, you use these two, and then you suggest certain solutions to the business to improve its profit and so on. So let's look at why Python is used in the finance side. So Python contains a lot of essential libraries that are needed in the finance sector. It is a high level programming language and it's very easy to start with. So for banking professionals who have no prior experience with coding, any language or Python, as a matter of fact, can easily pick up Python because it is so easy to read. It's more or less like English and it requires very less time to pick up. And using your banking skills, you can easily build on top of it. And due to these reasons, it became a favorite of Wall Street's big banks. And a lot of libraries were built on top of Python to aid, financial calculations. So these are the top 10 financial tools or libraries that Python provides. So you have NumPy at first, Pandas, SciPy, and you have the top 10. You can just research them one by one to know what each one does. Now let's look at the popular uses of Python in finance. So Python is used in stock price analysis. So when you want to predict the price of the stock, you can use libraries like Y Finance, which allows users to download historical data for analysis and processed using Pandas for manipulation. And you can use Matplotlib or Seaborn for visualizing the data to identify trends and patterns in the stock prices. Next, portfolio management. You can calculate key metrics in a portfolio using libraries like NumPy and Pandas that enable the handling of large data sets and allow for efficient performance evaluation and risk assessment of various investment strategies. Financial calculations. So Python simplifies a lot of complex financial calculations by providing libraries like NumPy. And if you want more advanced mathematical functions, you can use SciPy. So you can implement calculations like net present value calculation, internal rate of return, and so on. Algorithmic trading in Python uses several libraries such as Backtrader or Zipline to develop, backtest, and execute trading strategies. And using Python, much of this work can be automated based on predefined algorithms, and you can easily, especially for traders, they can execute trades efficiently based on market conditions. Risk management. So Python aids in risk management by enabling the development of models that assess financial risks using historical data. So you can use scikit-learn and This can be employed for predictive modeling to forecast potential losses or gains based on various risk factors. So data cleaning, you can do that with a Pandas library and exploratory data analysis. So you can use a mix of Pandas, Matplotlib, and Seaborn to clean data and visualize it to get some insights from it and hope to make better decisions in the future. Simulations. So simulations of, future financial scenarios is also possible with Python. So this was a brief about an intro to Python and why it should be used in finance. Now let's go over the installation of Python. Now to install Python on your desktop, you can just type Python ideally. You can go to download Python and just download the latest version for Windows. You can download this and just go over the instruction manual and get it downloaded. And now you are into the ideally shell. So this is called as the interactive environment. So in the interactive environment, the users can execute simple Python commands and run it in real time. So it gives you immediate feedback as soon as you hit enter. So you can just say have two variables x equal to 10, y equal to 20. Just say x divided by y 0.5. Okay, so this is the interactive shell. So there is another interface called the script mode where you can write multiple lines of code and then execute it as a whole. And this is useful for running larger programs that may consist of multiple lines of code. So that's all for this video. And in the next video, we'll look at the different IDEs that are available. Thanks for watching. Hello guys, this is Anirudh. This is our second video in the Finance with Python series, and today we are going to be looking at why you should use an IDE and the different popular IDEs that are available right now. So let's look at what an IDE is. An IDE is an integrated development environment. This is basically a software application that gives you facilities to combine essential tools like a source code editor, compiler, and a debugger all in a single graphical user interface, which can enhance the efficiency of a developer. So there are some advantages of using an IDE over a conventional IDLE platform. This isn't with respect to Python alone. So you get a streamlined workflow. So IDEs can consolidate various development tasks, allowing the developers to, write, compile, and debug all of the code in one place, which simplifies the development process and reduces the time spent switching between different tools. You can enhance productivity. So features such as syntax highlighting, code completion, error detection help developers write code more efficiently with fewer mistakes. Built-in tools. So IDEs often include version control systems, build automation tools, testing frameworks, making it easier to manage code changes and automate repetitive tasks. Immediate feedback is another advantage. So continuous parsing of code allows for instant feedback on syntax errors, enabling quicker debugging. So let's look at the different popular IDEs that are available in the market right now for Python. PyCharm is one of the most prominent IDEs that are available right now, and a lot of people or a lot of developers use PyCharm. So some features of PyCharm are advanced code navigation and refactoring, integrated debugger and test runner, extensive plugin ecosystem, version control integration, and it supports many web frameworks like Django and Flask. So let me just launch up PyCharm. So this is how the interface of PyCharm looks like. It's visually appealing to the eye rather than the conventional ideally, which which is very plain, and you don't have certain important features like auto code completion. And if you make a mistake, you wouldn't know, and you would have to go through all the lines of code one by one. And when you have a large project with multiple lines of code, it becomes very difficult, to identify the error. But when you use an IDE, the IDE gives you feedback on the code that you have written so that it makes your job easier. This is a very good tool for beginners who have just started out. But then when you want to develop more complex projects, then it becomes very difficult to manage different files. In this, you can't see which file, you don't have a file organization system on the side, and you need to keep switching tabs to, access different parts of the code if they are stored in different files under the same folder. So that is one of the big disadvantages of this. And you don't have auto code completion, which is, very effective and makes our job as developers very easy. Even though it's lightweight, there are huge drawbacks to this. So that's why people generally do not use ideally for developing. The next ID that we're going to look at is VS Code. So VS Code is a lightweight, powerful open source editor that is available for all platforms like Windows, Mac, and Linux. So one of the main features of VS Code is it's lightweight and very fast, and it has an integrated terminal. Let me just show you the integrated terminal. Yeah. So this is the integrated terminal that VS Code comes up with. So you can write all of your code here and execute it right over here, and you'll get the output here. It has IntelliSense for code completion, debugging capabilities. VS Code has a lot of extensions that can also help with development. So in relation to finance, let's just check the different extensions that are available. Just type finance and check it out. So this is a tool that gives you the right environment as a finance data analyst. So you might have to visualize a lot of, plots so that you can derive insights from it. So for all these purposes, these plugins are very useful. And there are a lot more plugins available here. For example, Storms is another popular plugin that, helps you get stock quotes, charts, and news. So there are a lot of, extensions available in VS Code, and that makes it a very popular platform. So the next ID that we are going to look at is Spider. So let's just look at the features of Spider. So Spider, the Python ID that scientists and data analysts deserve. So this is the type of ID that can carry out a lot of scientific calculations, and data analysts find this ID very useful because you have a debugger, a variable explorer. So all the variables that you're going to be using in your file are going to be available in this. There is also a section to visualize the plots that you're going to be using. So plotting is a major part of an analyst's job. So let me just give you some features about Spider. It has an integrated IPython console for interactive coding. In Ideally, I had showed you the different modes that you have, the interactive mode and the script mode. So in Spider, what Spider does is you have the interactive mode over here and the script mode over here side by side. So that is a very useful thing to have. So it supports scientific libraries like NumPy, SciPy, and Matplotlib that are used by analysts and scientists extensively. This is also a free and open source platform. So now let's just look at how much RAM or memory all these IDs use on your PC. So I'm going to just open up Task Manager and yeah, PyCharm by far is the heavyweight IDE. It uses a lot of memory, and right now it's at almost 1 GB, but at times it goes up to 2.5 GB as well. So if you have a 4 GB memory laptop, then it becomes difficult to run PyCharm on it because at times it will get laggy and it's very frustrating. So I would suggest you to look at alternatives like VS Code or Spider, so that these are a bit light on your RAM, 700 800 MB, maximum 1 GB. So you can run these applications very efficiently without any lags. So my personal favorite IDE is called as Google Colab. And Google Colab is essentially a cloud-based wrapper over Jupyter Notebook. And this is my personal favorite because in this, the files that you develop, the files that you save are directly integrated into Google Drive. Some key features of Google Colab are the fact that you get free GPUs and TPUs for training deep learning models, which is a great plus point. And if you have to perform a lot of heavy scientific calculations, then the access to GPUs and TPUs is very useful, and you get a lot of RAM and disk memory at your disposal. And collaboration is also possible with Google Colab. So you can share this Google Colab file to many users. So you can just go here. So you can just go here, type the email in. You can say anyone with the link and just put them as an editor so they can also edit the file along with you. So collaboration and free access to GPUs and TPUs is a great advantage of Google Colab. And a lot of Python libraries are pre-installed in Google Colab, and it reduces the need for manual installation. And Google Colab is built especially for data science and machine learning purposes, just like Spider. But I would definitely recommend Google Colab rather than Spider because it gives you access to a lot of GPU memory, RAM, and disk space. So this is not possible in any other IDE that you run. This is a cloud-based IDE, and even if something crashes, nothing happens to your computer. So if it crashes, you can just connect to another Google's backend PC. So when you connect to a runtime host, there are many options. So there are many options of when you want to connect to a runtime type. So there is the normal CPU. You have access to a Tesla 4 GPU and a TPU. So my favorite and personal choice has always been Google Colab because it gives you access to GPUs and TPUs. But other than Google Colab, if you have a lot of files and each file is in a different language. So let's say you're building a web application. So you'll have HTML, CSS, JavaScript files, and then you'll also have, let's say, a backend in Flask. Then VS Code is the best because it gives you an environment where you can integrate different programming languages in the same file system. So that is a big plus point of VS Code. Now let's just look at some comparisons. So this is the free edition and this is the paid edition. So PyCharm gives you just access to Python, Dart. You cannot develop applications in JavaScript or CSS. So when you want to build a web application, you have to go for the paid PyCharm version, or it's just not possible for you to develop web applications. So the free does not support Jupyter Notebook, any of these frameworks. So you can just look at the differences between the free and paid version. Another feature that I forgot to mention about Google Colab is that you get an AI assistant side by side. So when you type some code here for I in range and print I, okay. So when you do this, and you can just run it over here. And if you have some doubts regarding the code you have put or you're getting an error, you can just ask, hey, I am getting an error. Resolve, resolve it. You can just tell that you're getting an error, resolve it. It acts like your AI personal mentor or coach, as you call it, gives you some certain recommendations, and you can just copy paste the code here or make the necessary changes and it'll work. So I feel that is also a good plus point about Google Colab. So let's check this out. The spider advantage. Okay, as you have already seen, PyCharm occupies a lot of memory, and second comes VS Code, and third comes Spider. So they are arguing that Spider is sort of in the middle and gives you a sort of balance between uh, the power it consumes and the ease of use. But one thing I find conflicting with Spider is because I personally don't like the UI of Spider. I think it's very, very basic, and compared to PyCharm, it has a very bad UI. Whereas Google Colab gives you like a very good user interface, and it does not require power from your local machine either. All of it is fully cloud based, and even if a crash happens, nothing happens to your local environment. So there are a lot of advantages that come with using a cloud platform like Google Colab rather than a in-house ID on your local machine. So in comparison to PyCharm, Spider, and ideally Google Colab is the best for, data science purposes, or if you want to perform scientific financial calculations that require a lot of computations. And so for these reasons, I would highly recommend Google Colab as the best developing platform for finance related purposes. So choosing an ID always depends upon your use case. So if you're just going to develop only in Python, and it involves a lot of financial calculations. If you want to train a model and you want access to GPUs and TPUs, then Google Colab is the best application out there. Whereas if you want to build an application that is cross language, as in you need to use a lot of languages for it. Let's say a web application, you need HTML, CSS, and JavaScript, and a Python backend using Flask. Then you can use VS Code because it's lightweight, it gives you a lot of plugins as well. So that's all for this video, and we had looked at the different IDs that are available and the most popular ones, their advantages, disadvantages, pros and cons, and which ID to use for what use case. Thank you. Hello guys, this is Anirudh here, and welcome to yet another video on the Finance with Python series. This is going to be the third video in the series, and we are going to be looking at some basic syntax of Python and some pointers to keep in mind about Python. So let's just get started with data types. We are going to be covering a lot of subcomponents, starting with variables, data types, logical statements, for loops, while loops, how to write a function. The first component that we are going to look at is a variable. So what is a variable? A variable is a placeholder for information you want to store in Python and which you would like to recall later on during the coding process when you need to complete a certain action. So technically, the variable acts as an address for where the data is stored in memory. So let's just define a variable item. Let's say it's Apple. You can define another variable item and say banana. Now both of these are completely different variables because Python is case sensitive. So the capitalist I consists of a different variable. Next, let's look at the different data types that Python supports. So Python broadly has numbers. So numbers can be categorized into integers and floats. So integers are, for example, 1, 2, 3, and floats are 1.1, 2.3, minus 0.2, and so on. The next one is strings. Strings are placeholders that are used for text data, and you can manipulate them easily. The third data type that Python supports is lists. So lists are useful for storing a collection of items, such as transaction records, and so on. So let me just show you an example. Count equal to 1. So this is an integer. So we can just say type of count. Okay, it's taking some time to load. Int. So now let me define it as 1.0 and it will return as float. Yeah. And now these are strings. So let's just say type of item, str. So str is the abbreviation for string. The next one, the next data type is list. So let's just say L1 equal to, let's say a list of transactions, 1000 minus 2000, 3000, 5000. Now let's say type of L1. List. So L1 is a list. It is useful for storing a collection of items. So what is this green highlighted thing on here? So that is called a comment. So in Python, when you don't want certain lines of code to run, you comment it out basically. So in Python, putting a hash just next to the sentence, typing a hash at the beginning of the sentence completely comments out the line, and the line doesn't get executed when the code is running. So on to the next part, which is mathematical operations. So there are a lot of mathematical operations like addition, subtraction, multiplication, division, and so on. So let me just give you like a small, so let me just give you a small summary of all these basic mathematical operations. So you can print A plus B plus B. So these are very basic mathematical operations. You can add, subtract, multiply, and divide numbers. So the next three arithmetic operations are float division, modulus operation, and the exponentiation. So what is float division? So let's say A is 10, B is 3 as taken above. So if you do A slash slash B, so if you give just one slash, then it is normal division. If you have given two slashes, then it's float division. So yes, as expected, when you do a float division for 10 and 3, you get 3 as the answer. So float division, you get 3 as the answer because float division is an operator that rounds the result down to the nearest whole number or integer, which is less than or equal to the normal division result. So the normal division result was 3.335 and it rounds it down to the nearest whole number or integer, which is less than or equal to the normal division result. And hence it's 3. Now, if you print B slash A, which is 3 by 10, which is 0.3, but when you put in, just keep in mind that when you print B floor division A, you get 0. Why? Because 0.3 rounds off to 0, and hence you get the answer is 0. The next one we're going to look at is modulus operator. So with the same example, we can print A, and now the symbol that is used for the modulus operator is the percentage. So what modulus does is it returns the remainder of a division. So when you divide 10 by 3, you get a remainder as 1. So A modulo B gives 1. Yeah. Now suppose in this case A is greater than B, so you can get a modulo from it. What if you did B modulo A? You get 3. You get the modulus as 3 because when you divide 3 by 10, 3 is less than 10, hence 10 cannot divide 3, and the remainder just remains 3. So now the next arithmetic operation is exponentiation. So for exponentiation, you use 2 stars. Instead of a 1 star for multiplication, you use 2 stars together. So A star star, which is 10 to the power 3, which is 1000. Now let's look at some logical statements, if else statements. So if else statements are called as logical statements, and now let's just have a look at them. So now let's just say have a scenario where now let's just have a scenario where people above 18 are considered as adults and people below 18 are considered as children. So let's say age equal to 25. So it's obviously going to be adult. Now, if you want to take user input every time you run this for age, then you can just say age equal to, you take user input and it is of type integer. So you say input. Okay. And within these braces, you can give this sort of precursor to the input that you're giving so that you can explain to the users what kind of input it is. So you can say enter the age. So when you give this sort of precursor, the users know what they should enter and it's displayed in the command line. So yes, just like this. So now if I give 17, child. Yeah, this was an example of a logical statement. Now let's look at loops. What is the purpose of loops? So looping essentially means repeating something over and over until a particular condition is satisfied. And you have 2 types of loops in Python. A for loop executes a group of statements as long as the condition is satisfied. And it's the same with while loop. So let's say you want to print hello 3 times. Instead of printing say a equal to hello. Now you want to print hello 3 times, so you do print a, print a, print a. Now this is a very cumbersome process and it's just not that efficient. So what you do is you have a for loop for I in range 3, print a. So here, what you do is you loop. So I is a variable. So when you say for I in range 3, this line initializes a loop that will iterate 3 times. So every loop by default starts from 0 and it goes on until the value 2. So 3 is the upper value over here and the counter I can be less than or equal to 2 only. It cannot become 3. So I takes the values 0, 1 and 2. So when I is equal to 0, it prints hello once. When I is equal to 1, it prints hello. And when I is equal to 2, it prints hello again. So let's just comment this out and let's check the output. Hello, hello, hello. So we can also add the I over here just to see it. So str of I, what are you doing with str of I? So we know that I is a variable which takes integer values. So if you want to convert this integer to a string value, you just say string of I. So 1 or 0 is an integer initially, but when you say string of I, it becomes 1 but enclosed in quotes, which is a string. So let me print this. Hello 0, hello 1, hello 2. So let's take a sample problem just to illustrate how the while loop works. So let's say you want to accumulate a total sum of 1,000 rupees. So you store that variable called total underscore sum. And let's say you are able to save about 100 rupees every month after expenses. And let's say the amount that you are able to save increases by 5% every month. So 0.05. So now you want to know how many months it would take you to reach the total sum of 1,000. So in this case, you can use a while loop. So let's say right now the total amount that you've saved is 0. So you want to run this loop till the amount that you've saved is greater than or equal to the total sum. So while you run the loop, so while total underscore sum is greater than total saved, you run the loop. And so after every month, you increase by 5%. Total underscore saved. Yes. So I've just typed up the code for this small question. So what you do is every month you increase the saving by 5%. And every month you add that saving into the total saved. So after the first month, total saved is initially 0. And after the first month, it becomes 100. And the amount that you are going to save on the second month is going to be 105 because you are increasing the amount by 5%, the saving amount by 5%. So it's going to be 105. And now it will loop again. 105 is obviously less than 1,000. So it loops again. And you again go back, add the saving to the total underscore save and increase the saving for the next month. So now if you want to calculate how many months this will take, let's just use another variable called months. Initialize it to 0. When you add savings to the total underscore save, it means a month has passed. So you can say month plus equal to 1. So month gets incremented by 1. So now you can print total saved and months. Let's just run this. So by the end of the 9th month, you can save 1,102. And so you would need 9 months to save this amount. So the next component that we're going to be looking at is functions. So functions are usable blocks of code that are designed to perform a specific task. So they help to break down a very complex problem into very small manageable pieces, which improves code readability, reusability. In finance, especially functions can be very helpful in automating certain financial calculations. So now this is just a small example to calculate the monthly payment of a loan. And this is an example to showcase the use of a function. So the monthly rate is given by the annual rate divided by 12. So we have been given that 5% is the annual rate, which is 0.05 for 1 year. And converting that to per month, it is going to be 0.05 divided by 12. And the total number of installments and payments that we are going to be doing is equal to 12 into the number of years, which is 15 into 12, which is about 180. And so we can calculate the monthly payment using this formula. So right now you don't have to understand how or where this formula came from. And right now we are just trying to understand how a function is useful. So these calculations are very frequently done. And if you want to automate such tasks, you just use a function. And this is the framework of a function. So def here tells our Python code that this is a function, and calculate underscore payment under monthly underscore payment is the name of the function. And in the brackets, you've been given 3 variables: principal, annual rate, and term underscore years. So these 3 are called as the parameter that a function accepts. So these parameters are given different values, and using these values, it returns a monthly payment. So that's what this does. So it's reusable in the sense that different combination of these values gives you a monthly payment. So instead of trying to calculate it every single time using a different set of values, automate the whole task by giving it a framework. So inside the function, you do certain calculations. These are very basic math calculations. And after that, you need to give a certain output back. And that is given using the return statement. So what the return statement does is, this is the line for termination of the function. And you had called, and here you're calling the function and passing it some parameters. And the parameters have been given over here. So you're using a variable called monthly underscore payment, calling the function calculate underscore monthly underscore payment, and giving it these three parameters. So when you give these three parameters, it goes to this line, calculates all these variables, and returns the monthly payment. And the monthly underscore payment variable gets the value of this, and you can print the monthly payment. So this was just an introduction to Python programming with some basic math operations, for loops, while loops, logical statements, and how to write functions. And there are a ton of resources out there if you want to learn the inner workings of this. But for financial calculations, this much level of understanding is more than enough. And we'll be learning a lot more of these intricacies as we go along the series. Thanks for watching. Hello guys, welcome back to another video in the Finance of Python series. This is Anirudh here, and today we're going to be looking at the NumPy library. So NumPy, in short for numerical Python, is a fundamental library for numerical computations in Python. NumPy provides support for large multidimensional arrays and matrices, along with a collection of mathematical functions that you can perform on these arrays. And this is what makes it very powerful. Now, why do you think NumPy is so widely used across various fields? There are a variety of reasons, and some of them are the efficiency with which it is able to handle large data sets effectively, the speed with which it's able to carry out operations with these arrays. So if you want to perform complex arithmetic operations on two or more arrays, is able to manage this fast because NumPy has been the major chunk of NumPy has been built on top of C, making all these calculations and computations faster. And vectorization is another feature. So vectorization means you're able to perform operations on entire arrays without using loops, leading to more concise and cleaner code. And you also have an ecosystem in Python, especially because you can use NumPy along with Pandas and Matplotlib. So now let me just go over to the collab environment. So if you want to install NumPy on your laptop, you can just type in install NumPy. So that should work. Collab already comes with NumPy pre-installed, so you don't necessarily have to install it, but I'm just showing you how to install NumPy just in case. Okay, so now let's import NumPy as NP. Why do you think we should use NumPy? We have the list structure in Python. So why would anyone use NumPy? So just to show you the speed difference. So here we have tried to create two arrays, one using the NumPy a range function and another using our conventional list function. We can run this. Let's try to do some operations on these arrays that have been created, and let's compute the time that's taken. So let's use a time function, use a new array, and multiply the first array by 2. Yes. So this is how long it took for the NumPy array to get multiplied by 2 completely. Now let's do it with the array, the list. Percentage time it by 3 equal to my underscore list into 2. Yeah. So you can clearly see the results over here. So a normal list takes about 10 times more time, consumes 10x more time compared to NumPy. So this is the speed advantage that I'm talking about, and this is per loop. So now when this is compounded over huge data sets, it makes a really huge difference. And so when there's a lot of data, especially in the field of finance, when you are analyzing a lot of real-time market data, you have a lot of variables. It is always wiser to use NumPy rather than a regular array to store some of these values, because you can perform certain computations on data stored in NumPy arrays in a much quicker manner. So we have tried to showcase the speed difference here. Now let's go over some basics of NumPy. How do you create a basic array? So data equal to NumPy dot array of, let's say you want to create two-dimensional array. 1, 2, 3, 4, 5, 6 data. So this is how a NumPy array is represented. Then let's do some operation on the data array that we've created. Data to 10. So you've multiplied by 10. These are some basic operations that you can do. Then you can add the arrays together. Yes. Now, if you want to get, the dimensions of the array, you can give the data dot shape function and you'll get it. Now you want to see the data type of, the array inputs, then int 64. Yes. So all these are integers. So let's now just see how to create a NumPy array from a regular list. So let's say you have a regular list like 6, 7, 8, 9, 10. You can just use another variable called, let's say, NumPy underscore array equal to np dot array of data 1. And sorry, just, yeah, and now print. Yeah, so now this is a NumPy array. In addition to the NumPy dot array function, you have a number of other functions for creating new arrays. So for example, if you want an array with just zeros or just ones for a specific dimension, you can do that as well. So let me show that. P dot zeros. You just want zeros, and now let's specify a dimension. Let's say we want a 4 cross 3 array. sorry, a 4 cross 3 matrix filled with zeros. We have a 4 cross 3 over here. Now, if you want them to be filled with ones, just say np dot ones 4 cross 3, and you'll get ones over there. It's pretty basic. We also have a dot empty function, which will just create a new array by allocating new memory, but it will not, populate the array with any sort of values. As you can see, if I take another dimension, it's very random. There are some zeros here and there. There's a random value. So it's not necessarily fully one or fully zero or any specific value. It's just filled with garbage values unless you populate the array with new data. Now let's move over to some arithmetic capabilities of NumPy arrays. So here we'll be looking at certain features like vectorization. So we have, let's start off with a new array. And now let's calculate array into array. Yep. So here you can multiply the two arrays. So what it means is that you are just multiplying the elements of corresponding positions and making it into a new array. You can add arrays, you can subtract arrays. So all of this is possible. You can also do a one by the value of the arrays. So it's basically like this one by ARR. So you get 1.5, 1 by 3.33, and so on. You can do your exponentiation and all of that. You can also compare the values of two arrays, using, let's say, a logical statement. Let's take another array. So this is a new array that we are initializing. Now, let's say you want to see if the elements of the second array are greater than the elements of the first array. So you can just say array2 greater than the array that we initialized. And you'll get a Boolean sort of output, which gives you the answer for each and every cell of the array. So just like how in loops we have the range function, in array it is called the arange function. So here you can construct an array with very specified, with some specifications. So let's say you want the first 10 numbers with, let's say, a step size of 2, starting with 2. So 2, 4, 6, 8. Yeah. So this is possible. Instead of, writing loops, you are just able to pass it through a function. So this is a classic live example of the vectorization property. Now, the next thing we're going to be talking about is slicing of arrays. So after initializing an array 5, okay. Now let's say you want to access a certain portion of this array using the slicing operation. So you can say 5 is to 7. So you'll get 5 and 6 element, 5 till the end. So from the fifth index till the end. You can also do negative indexing. So yes, so let's go -5, -8. Oh yeah, I just forgot to mention -1. Yes. So 5, 4, 3. Yeah. So now we were able to access this particular element using this indexing. Yeah. So in this way, you can access individual elements inside the array using the slicing operation. So the next operation that we are going to look at is reshape and transpose. So what transposing does is pretty simple. So you have array. Now, if you do array.transpose, it'll just take the transpose. This is very basic. The next one is the reshaping function. So let's say you have an array. Let's just reinitialize the array called np dot of 10. And now you want to reshape this into, you have 10 elements, right? So you can say a 2 comma 5, 2 comma 5. So now print here. Yeah. So you have successfully managed to, rearrange this array into a 2 by 5 matrix, 2 by 5 matrix. So 2 rows and 5 columns. Another operator is the dot product. So you can easily take dot products using the NumPy dot operation. So you can just say NumPy dot give the two arrays that you want, two matrices that you want to take the dot product of. And just click enter and it computes it, and it is as simple as that. I would suggest you to go look into some advanced topics like broadcasting rules for NumPy arrays. This can give you some insight on what are the different rules for dot products apart from the fact that you know the number of columns of the first array must be equal to the number of rows of the second array. So there are some rules and regulations on how NumPy dot product has been constructed. So I would suggest you to look into that specifically. So the next feature is the ability of NumPy to generate random values. So the NumPy.random module is able to do this. So if you want a standard normal distribution of values, you can just say, and here you can give the dimensions of 5 comma 5. Oops. Yeah. So here you get a standard normal distribution of values, and these are randomly generated. You can also do np dot. You can also complete the square root of the whole array that you've generated. So let's say np dot square root of the samples array itself. So you can take the square root. Yeah, some of them have NAN because obviously they are negative numbers. This is just an example. And you can also take the exponents of samples. Yeah. So np dot maximum function is another function that is used to compute, that is used to take the maximum values on two arrays and make a new array from it. So I hope these two arrays are similar. Okay, it's 2, 5, and 2, 3. Okay, let's just array and array 2. Okay, let's just run this as well. And now we can run this. Yeah. So 1, 4, 3, 7, 5, 12. So we have a 4 over here. Why? The reason being, let's just go to ARR. Yeah. 2 and 4. 4 was evidently greater. So 4 came in place of 2. And this way, similarly, you can just compare, NumPy just compares the elements and sort of puts it up in the new array. Yeah. So there are a lot more functions, like you can do sorting and a lot more of it. I wouldn't go into too much detail. Whatever I've covered till now is more than enough. to just get you started with the NumPy. And as you try to, do different, as you come across different use cases, you will learn about, different options in NumPy or different functions in NumPy that you can use. And one small short tutorial it's not possible to cover everything in a short tutorial. But now I hope that you guys have a basic understanding of, how NumPy works, what the know-how of, how to do some basic to intermediate level stuff. Now another feature that is there in the NumPy library is the NumPy financial segment of the NumPy library itself. So this particularly has financial functions, and this is very useful to calculate certain frequent calculations that are performed in the financial world. And let me just try to showcase it to you using some examples. I think we need to install it using the pip NumPy financial. Yeah, right. So never mind. Oh, oops. Yeah. So now let's install the NumPy financial library and import NumPy underscore. Yeah. Now, there are a lot of financial calculations that you do regularly, like computing future value, computing the interest portion of a payment, calculation of internal rate of return, modified internal rate of return, net present value, and so on and so forth. So there are some, you know, functions to assist you in these very frequent calculations so that you don't have to code all of this out. So let's say you want to calculate the internal rate of return for, a set of cash flows that you've been given. So NPF dot IRR. So you have all these different options that are available as part of the NumPy financial library. So you can say NPF dot IRR given, the cash flows. Just taken some values over here and just print it. So for these set of cash flows, this is the IRR. So now you get the brief idea of, some very good features of NumPy especially. So you can look up on this website where you have different functions provided, especially under the NumPy financial package. Don't forget to download the NumPy financial package using pip. So yeah, that's all for this video. Thanks for watching again. And I hope you guys can, try out some financial examples by yourselves. This was just a brief about the NumPy library and how powerful it is, why it should be used. Thanks for watching. Hello guys, welcome back to another video in the Finance with Python series. This is Anirudh here, and today we are going to be looking at an introduction to Pandas. So we are going to be taking the ICICI Bank stock data, and we will do some manipulation over this data, and I'll show you different functionalities of Pandas using this. And I highly recommend you to watch the previous video that I had made on the Y Finance library, just so that you know what Y Finance is and how you import data from it. So now let's get started. So here I'm just going to install Y Finance and import it, and I'm downloading the recent data of ICICI Bank stock for the last 1 day with an interval of 1 minute. So I've just taken the last 5 values of this stock just before it closed. You can, if you want to visualize the whole data, let's just say data 1. So it opened at 3:45. This is according to the UK Standard Time. India is 6.5 hours, something ahead. So you can calculate it accordingly, plus 5:30, yeah, 5.5 hours ahead. So that's when Indian market starts and it closes at 10 according to the UK standard time. So anyways, leave that. So now let's import pandas. And now what we're going to do is let's just look at some basic functionalities of pandas. So what is pandas? Pandas is a very important library that contains a lot of data structures and data manipulation tools that is designed to make data cleaning and data analysis very fast and convenient in Python. And pandas is often used along with tools like NumPy and SciPy and a lot of other analytical libraries like stats models, scikit-learn, and so on. Pandas has two main data structures. One of them is called as series, and the other is called as the data frame. We are going to be covering data frame extensively in this video, but let me just tell you what a series is. So let's quickly define a new series. Series. So this is a series. So as you can see, I have defined a series over here. And for each element of the series, you are given a corresponding index 0, 1, 2, 3. So series is like similar to dictionaries. And each of these, data values have a corresponding index associated with it. And that is what you are visualizing over here. So this is a basic series. So you can think of it like this. The counterpart of series in Python is a dictionary. And if you want to access elements of a series, it's called obj. So obj of 1, you'll get 5. Yeah, took a bit of time, but it does work. Now you can also do slicing over it, and you'll get 5, 6, 7, so on. So you can do all sorts of stuff like that. See that here. Okay. Now you can also specify, you have these indexes 0, 1, 2, 3. What you can also do is you can also manually, sort of give an index for it for each of these elements, corresponding elements. So you can say X, and can have the next value as Y, with this Z, now this as A. Now you can see that the indices have changed. So now I can also get of X. You can, oh, sorry, think this should work. Yeah. So you can reference elements from the series like this. Let's see if this works. Yeah, this also works. So let's try something more interesting. So, okay. So you can also perform slicing operations over the series in this manner. Next, let's also look at, so if you want to, print the indexes alone, so you can just say object.index, you'll get the data type as object and the index values X, Y, Z, and A, so on. So these are the very simple basic stuff. Now, if you want to alter, one of the values over here, let's say I want to change Z as -2. So you can say obj of Z equal to -2. Done. And print obj. Yeah. So, you can do this also. Just, changing values over here. This is something more interesting. Now, let's say you want positive numbers from obj. So you want, let's say, Y, which is 5, and A, which represents 7. So you want these two elements alone. You can say obj greater than 0. Yeah, you get 5 and 7. If you want something that's lesser than 0, negative ones, it's also you get it. You can also multiply it by 2 and, obj into 2 plus, let's say, 3. Let's see what happens. So we multiplied the whole thing by 2. So minus 8 plus 3 minus 5. Yeah, perfect. So you can do such arithmetic functions over the series. So the main idea of pandas is, you can do a lot of manipulation with different types of data easily. That is why pandas is very useful. Mm. You can also convert, the pandas series, the series data structure to, a list data structure. So you have object. So you have obj. Obj is an object, or you want to convert this to a dictionary and do that. Uh, Run it. You want to store this in something, obj1 and obj underscore dict. Yeah. No. Obj underscore dict. Yeah. So this is also possible. I'm just showing you right now some, very basic functions of pandas and something that should be known. Mm. Now let's, yeah. Now let's look at the, now let's look at dealing with null values or missing or NA values. Okay, so now let's just define another series, null series, let's say panda dot series of, well, let's give -4 null. Oh, sorry, it's np dot none. I can also give it as none. None, let's say 6, 7, give indexes to it. Yeah, let's just do this. So you can see that, y references a null value or, an NaN. So now if you want to see how many, if you want to, check if there is an NaN value in this, say null underscore series dot is NA. This should work. Yep. Is NA. So you can see that at y it gives true. So y is an NA. And not NA, it's like the opposite of is NA, obviously. So X is not an NA and so on. So you get the brief idea. You can also give it as is null. So that also works. You can use all these, 3 variations. Now we have looked at, we have looked at series data, the series data structure. Now let's move on to the data frame data structure. We have another, data structure in Pandas called as the data frame. So this is basically a rectangular table of data which contains an ordered collection of columns, and each of which can be, a different value. This data frame is more like a table, and it has both a row index and a column index. And it can be thought of as a dictionary of series, all sharing the same index. Now let me just try to use a data frame like this. Data DFF. Yeah. So this is how a data frame is, defined. So you can see here that, it's a dictionary of different series. So this over here is a series, this over here is a series data structure, and this over here is a series data structure. And the dictionary of the combination of these series data structures forms a data frame. In simple words, data frame is just, like a table format in which data is embedded, and you can do some magic on, the data stored in the table. And, you can this is really helpful in, data analysis and data cleaning and a lot of, data manipulations. Okay, now let's look at DFF. Now you want to convert this into a data frame, right? We could have just done that here. So pt dot data frame. Yeah. And now just visualize the FF. Yeah. So now you get this, beautiful looking table over here. So evidently you have rows and you have columns. As in, okay, so these are called as the column references. So state, year, and pop are the columns of it, and 0, 1, 2, 3, 4, 5. These are the indexes of this data frame. So if you want to change the column names of this data frame, what you can do is you can just say you take another data frame, pd.data frame of the original data frame with index. Sorry, it's changing the columns. So you say columns equal to, well, you can just use, we had state here, pop here. So we can add on, say state here, pop, population, and you can also say mortality. You haven't explicitly given, values for mortality over here. So let's just see what happens over here. Since you haven't given values for mortality, what happens is it just references it as NaN. So now let's say you want to update a particular mortality. Let's say the mortality at well, Nevada. Okay, so let me try this. This works. Okay. So now let's look at frame. Let's just do this. Yeah, let's look at yeah. So you can see that the mortality has become, okay. We have a problem here. Okay. So what has happened is everything has gotten, updated to mortality. Okay, let's try that again. Dot yield. Let's try that again. Okay. Now we need to take this off. We don't need this column. There was a brief error I made here. So I'm going to also be talking about the LOC and the ILOC, functions. So LOC is basically a locate function. So if you want to locate any particular element in the data frame, you can just say locate the data frame dot locate, and give the row index and the column index. So here the row index is 3 and the column index is mortality, and you want to reference it to 100,000, and now we reference it. You get it, right? So we want to drop this column because it's undesirable and made a mess out of it. So what we're going to do is, yeah, so we finally managed to drop this column. So you can just store the name of the column in a variable and use the drop keyword, and then yes, you've successfully dropped that column from the table. Okay, so now you can also do this dff.describe. So this gives you the count, mean, standard deviation, minimum, 25, 50, and 75, 75%, the maximum, and so on. Now let's try to work with some stock data. Now that you've learned some basics, there is a bit more that I need to cover. Data one, data one on this drive. Okay, now you get this information. So if you just want, a brief, understanding of how the stock is performing, you can just say data one dot sample. It gives you a random value. And if you want to sample a specific number, give the number and you say, you get very varied, different prices at different times. Not that useful, but sure, you can get an idea. data one dot info. Let's see what info gives you. So it gives you what all column names you have. Okay, now let's do something more interesting. Let's say you want the adjusted closing price alone. So let's say adjusted underscore close equal to of and now you want this alone and you want it's just sorry, let's just print this. There's a lot. Okay, let's just print the last five values. So here you can get the adjusted closing price of the ICICI Bank stock alone instead of every other thing. Let's look at how to filter the data based on a given condition. Yeah, filtering. Filtering is something you could do on stock, the stock. So filter equal to, let's say you want you know specific time periods when the ICICI Bank stock went above. Let's say here it's 1265. Let's look at this. Okay, it was maxed out. The highest was 1285, and let's look at the 50th one, 1263, 1266. So let's look at when it went above 1,275. Yeah. So that looks like a good price to sell from what I see. Do you see any 1275s out here? Uh, Not really, but okay. Let's go over. Let's filter data. Find when the stock went above 1275. So data one of adjusted closing. Yeah. Let's take the adjusted closing. Okay. Filter equal to data one of filter the data. Now print. Let's see on what all instances. Okay, a lot of instances. So let's give a more higher value. Okay. Oops. Hmm. So on all these instances, the stock value went over 1279 rupees. Now, if you want to access multiple columns, it's just the same as accessing one column. So let's say you want to access adjacent close and volume. You can just reference it as data one of take adjacent close of ICICI Bank. So now you can just give us you want these two particular columns. Yeah, let's show these columns. Now you get these. You can access multiple columns, so that is possible. We've looked at filtering data. Now, okay. Now, if you want, to create a new column on this, so let's call it, a difference column. The data one of difference. You want some sort of difference. This calculates, the difference between the high and the low. Data one of data one of low and data one dot tail. Yeah, let's try this. Works. So we have successfully created a new column over here. So we can get minute by minute, the difference between the high and low. You can also see this is a very basic thing that I've done here. But if you want to interpolate more results from these values, these particular values, using volume, open, low, high, close, adjacent, close, and so on. ADJ close, adjusted close. You can do that as well. Mm, let's also create another, you know, thing called squared adjacent close, right? Let's say this is data one of adjacent close. So what you want to be doing is, squaring every value. So you can do this. You command tail. Let's see if this works. Yeah. So you have the difference column, you have the squared adjacent close. You have also given a square root. The square root should be appealing to the eye. What is the error? What happened? Yeah, it works. I think there was some particular value where it was less than zero or negative, and because of that reason, it just gave any values. So I think you just confirm that. So you can just use an NP where to give a conditional statement saying wherever it's greater than zero, compute the adjacent close square root, or input it as an NAM. Simple enough. So now the last thing that I'm going to be covering is the rename function. So if you want to rename this, so I've obviously made a bad spelling mistake over here. If you want to, rename this, you can say data one dot rename of it's a column. So columns equal to, and let's just copy this. I want to correct the spelling mistake. So that's my intention. And now let's give the right spelling as QAR adjacent close, right? So you've done this. And now you can give the in place argument and give it as true, so that it directly references it to the data frame instead of just showing it as a new data frame. Here you can see that the spelling mistake has been corrected. There is also another function called as the value count. So data one, let me just show you how that works. So if you want to drop a particular column, you can just give the drop command. This will drop this whole column. Yeah. So the column has been dropped. So data one, data one of adjacent close. You want to count the number of instances when the adjacent close price went greater than 1 to 75.0, 375 instances. So this was just a brief. So I think I've covered a lot of useful functions and options available in Pandas. There are some small things that I didn't cover, like how do you import data from a CSV file or an Excel file. These are very basic, and you can just you know let me just show you the format. You have a lot of formats to import data from. So you have the CSV, you have the Excel file, you have the Parquet file. Parquet, and Parquet is very popular because it uses very less memory, so on and so forth. So let's say you can reference something as data two equal to, and you can just give pd dot read underscore CSV and give the file location in the brackets, and you can easily import any sort of you know file. So let's just look at the different options available here. We have CSV, Excel, Feather, HTML, JSON, Parquet, so on and so forth. So that's the small thing that I wanted to show you. So I think we have sort of covered all the basics that's required. This should be a good, you know, stepping stone for you to learn advanced stuff. So something that I would like you guys to look at is, looking at rejects expressions, uh, that has a lot more functionality involved. You can do a lot more of data manipulation using that. So that's something that I would advise you guys to look at, rejects expressions. Apart from that, we have covered a lot of basic stuff. We have used, by finance, imported the data, filtered it, accessed, particular elements, and put up new columns, so on and so forth, using, the stock data. We had also looked at, basics of pandas like series, data frames, you know, accessing a particular element, changing the index, changing the column name, dropping a column, locating a column, and so on. So that's all for this video. I hope you guys enjoyed it. Do look at regex expressions. Pandas are very important. And that's all for this video. Thanks a lot for watching. Thank you. Hello, guys. Welcome back to another video in the Finance with Python series. This is Anirudh here, and today we are going to be going through some data visualization tools. The two main data visualization tools that we're going to see today are Matplotlib and Seaborn. So Matplotlib is a low-level graph plotting library in Python that serves as a visualization utility, and it is open source and you can use it freely. And Matplotlib is mostly written in Python with a few segments which is written in C. So Matplotlib provides extensive customization options that allows users to control every aspect, of the plot, including the axis, the color, style, and so on. But compared to Seaborn, Matplotlib requires more lines of code to produce, similar visualizations. So that is probably one disadvantage. And Seaborn is fairly, you know, recent, and it is built on top of Matplotlib. And you know, the aim is to simplify the creation of complex visualizations, and it also enhances the aesthetic appeal of the plots. Okay, so now let's get started. So Matplotlib has, a pyplot submodule under which most of the utilities are present. And, you can usually, it is usually imported with a PLT. So you just import matplotlib.pyplot as PLT. And as to how you want to plot these graphs, you can give a bunch of X coordinates, you can give a bunch of Y coordinates and plot it. It is as simple as that. You can also give customizations over here. So this is the line style customization that you have here. Now, instead of dotted, let's say I want something else. Yeah, we can have a dashed line, let's say. So when you input that, you get a dashed line over here. You can also, instead of writing it in such a big, sort of manner, you can also simplify it saying ls equal to, um, yeah, this is, for the dotted. And for dash, we can give it as like this. So ls in short form for, line style. And here, this is very, very easy to understand. Like you can give the x-axis label, x-axis, and you can give the y-axis label as y-axis. I can change this up, say x coordinates, and let's give y coordinates. Change that, and it'll just show. So this is very basic. Let's go on. You also have a, you can also create this sort of bar graph between the x and y variables. So x equal to 1 is 10, right? As you can see here. And according to that, a bar graph is created. And you can also create a scatter plot. You can do all sorts of customizations with the matplotlib library. Also, something that I didn't mention is okay, you can also give it like this. So instead of calling it as plt.scatter, you can also give another argument saying, yeah. So this is the same as a scatter plot. As you can see here, these two are the same. Yeah. So this references a scatter plot, the small o. So it just means that all the data points are going to be represented with a circle format, small circle o. Yes. Now let's look at markers, right? So let's go back to the initial dotted lines and let's also give a marker. So what is a marker? Marker is like, you highlight a particular point using a certain type of symbol. So let's say star is the symbol. So on a dotted line, you want to represent, these points. You want to highlight these points. So you use a marker for it. See? So you mark this. Yeah. So that's the main job of a marker. It just draws your attention towards specific points. You have a lot other markers like, let me just show you. So let's see all the available markers over here. Yeah. You have zero, which is a circle. You have descriptions for everything. You can do a point, comma, small x, big X, plus. Let's try this one, the last one, underscore. So it's called as a hedge line. You can see that the underscore is found here. So these are called as markers. We can do a bit more of experimentation with this. So now let's try, this sort of small um, let's try a customization now. So let's say you want the marker to be a circle. So you give O, right? So essentially this is a marker. And you also want, let's say, a dash line. You can give a dash. You want the color to be green, so let's give green. Let's see what happens here. Yeah. So you can see you can give these three in this sort of short form, and this makes your life very easy. You can give a dash line also. You can change up the marker, you know. Okay, comma. It doesn't reflect, obviously. Let's give X. Yeah, so you can see X over here. Yeah. So these are some, small customizations and certain interesting things that you can play around with. Okay, so let's delete this. We don't need this. Yeah. Now, now what we're going to do is we're going to look at an actual stock data set. Let's say Google. So, we're just importing Y Finance, Matplotlib, and Seaborn. These two are the visualization libraries, and this is just, another library to get sort of real-time stock data. Yeah. So you download the data, store it in the data underscore Google, and now you are creating a figure. So what the dot figure does essentially is you just get this sort of palette of 10 cross 6. So the width is 10 and the height is 6. So that is what 10 cross 6 means. So let me just, separately run that so that you can understand what sort of outputs. Yeah. See, so you can see that you get a figure of this particular size, right? Yeah. So just, need this now. Huh. And you are, what is this plot showing? This plot is showing, the closing price according to the dates. So x-axis is the date and y-axis is the closing price. I've given the data underscore google dot index over here, the dot index over here, because let's just look at how the data set is. Yeah. So these are the indices, the dates are the indices. So that's why you have given a dot index over here and you're referencing it with, the closing price and you're giving the X and Y axis labels and the title. Yeah. So you get this sort of plot when you run it. Just run it again if you want. Yeah. Now, what sort of customizations can we do in this? Let's say I want a dotted line, you know, yeah, dotted line. Marker, sure. It's going to be very cluttery, because I've added the marker. It's going to be very cluttered, but yeah, I think we can stick with this. This looks more appealing to the eye. Yeah. Now in this, we are just, plotting the volume of the stock along with the date, right? Just similar to the closing price, you're just plotting the stock. Sorry, you're plotting the volume of the stock day on day, you know. We don't need a marker over here. So now I had implemented, the stock price according to the date on Matplotlib. So now let's try it with Seaborn. Oops. Let's try it with Seaborn. Run this. I've just done the same with Seaborn. So you have a dot line plot function in Seaborn. You can specify the X and Y axis. Very simple. X axis is the index, which is the date, and Y axis is the closing price. Now we have tried to, flatten these values because as you can see in our data set, the closing price is not exactly one dimensional, right? So dots, we can just look that up pretty quick. Yeah, it's not one dimensional. So you want to extract this part alone. So you just flatten it. I flatten it over here and then I use it. So let me just show you what happens if you don't flatten it. It'll just show you an error saying, you need a one-dimensional, but got an n-dimensional array instead. So it's just, much easier to just flatten it. So these are some tricks that you can do. Yeah. Here we have made a histogram plot. Okay. Now we are looking at, the distribution of Google's daily return. So now what you've done here is how do you calculate the daily, return? So previous day closing price and today's closing price, you take this sort of delta of it and do a percentage over it. You get, the percentage of daily return. And that is essentially what you've done here. You've just made sure that, there is no bad value, as in there is not an NAN value over here. So we've dropped all those uh, NANs and we have arranged this into, bins of, 30 intervals. That is what bins equal to 30 means. And KD is called as the kernel density estimate. So this is the sort of curve that, it sort of provides, a smooth representation of the distribution. And that is what the kernel density estimate does. KD is like pretty, useful to visualize. Now, we can also visualize, the volume and frequency distribution. Yeah, so look at that. This is just another Seaborn visualization. We use another histogram plot, and here instead of here, you're taken like the closing price to calculate the daily return, right? Here you're just using the volume versus frequency. So stock volume distribution. This is just a volume distribution plot using Seaborn. So here we had seen that you had, plotted it over here. This did not, look appealing to the eye. Like you can't visualize anything from this. But when you look at this plot, this seems, a bit more appealing to the eye. It's like you can understand something from it. See, you can see here that, the mode of, the stock traded is this one, this big line over here, this big bar over here. That bar is like uh, the most frequent volume traded, which is around, I would say, 0.25, somewhere around that range. Again, this is all, brought down to, minute value. It has been scaled down. So just ensure that, the scaling factor is right. Now we can also have a correlation matrix, so SNS also, Seaborn as an SNS also gives you an option to have a heat map. So what is a heat map? So heat map is like a big matrix, and every it is color coded based on the corresponding correlation with different variables that are involved. So open, high, low, close, volume. These are the five variables. You take a correlation matrix, store it, and you take the heat map of this matrix, right? So you don't have to, get scared of what all each of these are. These are very easy. FMT means is just that, you're rounding off to two decimal places. Cool warm means that, blue is like the lower end of the spectrum and red is the highest end of the spectrum. Annotations is true means you just get all of these, annotations. So open good, high good, those are all called annotations. And you just give a title and show the plot. So from here, you can see that, let's try to, understand something from here. You can see that the amount of volume traded, directly affects the opening, high, low, and the close price, right? So that's what you can see from here. And most of them have very similar correlations. Yes. Now let's look at the next plot. Next plot is going to be another percentage change. So what we are trying to do is this shows you the volatility of the stock over time. So we have calculated the returns over here. So what are we essentially doing here? So we have the close price. We are taking the percentage. Sorry. So the percentage of close price over a window of 21 days, we are taking that and computing the standard deviation. That is the simplification of these two statements, right? And now we have calculated these two parameters and then we just, simply again plot it. The plotting part is very easy and this is the more important part to say. So you should know what to plot. Plotting is not the hardest part. Knowing what to plot and how to gain, you know, how to gain insights from it is more important because you can also plot stuff like this. You can't make out anything from this. This is like so cluttered. But if you want a much better plot, you should look at, a 21-day rolling window. Instead, you should have a plot like this where you can actually visualize something. You can actually see that the most frequent traded volume is this big bar over here. So things like this you just have to keep in mind. Now, let's also look at how to get the traditional candlestick pattern. You know that's what is more useful, right? So we have a library called Plotly. Okay, so this is an open source library, and this gives you the candlestick option. Uh, Matplotlib and Seaborn do not have this option, so we can use the candlestick option to sort of you know visualize the opening and closing price as it is seen in the trading platform. So let's go to a popular trading platform like TradingView. So let's just click ICICI. Yeah. So you can see the candlestick pattern here, right? This is what the traders want to look at. This is what is interesting for them. Yeah. So that's what we are trying to do here. And when you go over this, you can see the opening, closing factors, up here. This one. You can see that opening, high, low, closing. You can see all of those for each and every candlestick. And that's what Plotly allows you to do over here. So you can just click over here, you get the date, opening, high, low, close. So this, I would say, is a very useful tool in, in, in reference to how you perceive stocks. Very useful. So anyone wants to build a dashboard and they sort of want to show a stock, they can use the Plotly library and simply do it very easily. Now here, we have done a bit more of manipulation on, the variables. So here we have tried to calculate the moving averages. We've calculated the 50-day moving average and the 200-day moving average. So what is a simple moving average? So here, here you just sort of take the closing prices over a 50-day window, right? The window is 50 days and you take the mean and plot it. That's what you've done here. It gives you this sort of graph, which means that it gives you the average of the 50 days before the day. So this is the average of the last 50 days starting from here. And this point is the average of the last 50 days starting from here, right? And similarly, you have a 200-day moving average. So we have sort of wanted to plot this. Similarly, you create a figure of a certain figure size, plot the data. What do you want to plot? You want to compare the SMA 50, SMA 200, and the closing price, right? So you plot them with different colors, give them, the appropriate labels. So you have the labels over here and with colors blue, red, and green, right? So you're labeling them, giving the title, which is over here, the x-axis, the y-axis, you give the grids and you show the plot. So this is a brief tutorial on powerful visualization libraries, how they can be used effectively to give you maximum visualization and insights on your data. Also remember, visualization is easy if you know what to visualize. So I would like to end the video on that note. Thank you. Thanks for watching. Hello guys, welcome to another video. This is Anirudh here. And in this video, we're going to be going through how we'll import market data from Yahoo Finance API. So Y Finance is an API which is able to get real-time market data from the Yahoo Finance webpage. So this is the Yahoo Finance webpage, and we can just search up any random stock over here, let's say Microsoft. So you get certain measures over here, let's say previous close price, open price, the bid price, asking price, and there's a lot of data over here. So what Y Finance does is you can get all of these data into, let's say, your Colab environment so that you can do some calculations over it and assess whether to buy a stock or sell a stock, when to buy, when to sell, so on and so forth. So let's get started with installing Y Finance. And it's import Y Finance, import Y Finance as YF. Now, what you want to do is you want, let's say you pick a particular stock, Microsoft, as I mentioned before. So let's say data is equal to YF dot ticker. of MSFT. So this is the code name for the Microsoft stock, and ticker is sort of the code name that is given for all these stocks. So the ticker for Microsoft is MSFT. So let's just put MSFT over here. So we have the data of Microsoft stock inside this. And now let's say data.info. So you get some info about the Microsoft stock. Yeah, there's a lot of info here about Microsoft stock, the address, so on. It's a technology company and a brief summary. Oh, you also have how many employees are there and the top company officials, starting with Satya Nadella. Oh, you have his total pay, which is around $8 million per annum. That's insane. Okay, so here you get a lot of information about the stock. So now if you want a particular measure from all of these components, you can just say, let's say you want 52-week change. Yeah. So it's a very tedious process to go through all of this and search where 52-week changes. So you can just say data.info of 52-week change. And you'll get the 52-week change alone. So you can do this as well. Now let's say data.splits. This indicates how often the stocks have multiplied. So after every 2 to 3 years or so, it has been multiplied by a factor of 1.5 or 2 predominantly. So that is another measure. Now, if you want to check the major shareholders in Microsoft, you can say data dot major holders, and you get the percentage owned by different entities. So you have insiders, as in the employees who hold 0.0, a very minute amount. Institutions hold a major amount of about 73%. Moving on. Now, if you want to see the major, you want the names of institutions, you can say data dot insider roster holders. Okay. So these are the insider people, as in the company employees who own the maximum amount of shares, starting with, okay, Satya Nadella has a lot of shares, almost 860,000 shares. Now, if you want to see which institution holds maximum shares in Microsoft, you can just say data or institutional holders. Yes. And, yeah, no surprise here. It's always been Vanguard, BlackRock, and State Street that own major chunks of companies throughout the world. They have always been top three in every big company. Although it's not, these three companies are not very well known, but they own a major portion of our world. Now, if you want to check the dividends that that shareholders have gotten over the years, let's say data dot dividends. Yes. So it started with 8 cents per share, and now it is at about 75 cents per share. Wow, that is quite the growth. And this is per share. Now, let's say you want some financials data dot. So let's see what all functions are available. So let's just say data dot, and you get all of these functions. So, well, let's just say balance. Let's go with balance sheet. And, mm, get insider purchases. Okay, what does this do? Um, earnings, cash flow, capital gains, balance sheet. Yes. So you have the balance sheet over here. You can also say data dot cash flow. So these are various parameters, you know, that are used when deciding whether to invest in a stock or not. So you can look at how much debt a company has, amount of free cash flow, um, and the amount of you know volume, how much volume of the company stock has been traded in the near past. And if you want to look at the history of stock prices, you can say data dot history, uh, and you have to mention a time period. Let's just say maximum for now. So yeah, you can see that it started with just 5 cents. Now it's at $426. That's quite the progression. And now let's give a period of the last 1 year. Uh, then okay, sorry. Yeah, yes. So the last 1 year it has grown quite significantly. It's very evident just looking at the start of the year and the end of the year. So overall, Microsoft has had a great year so far. Now, if you want to mention a specific range, you can just say start is a particular value, and you can also give an ending value. Let's say start is 2000, 2010, 04, 05, and you want it till December of 2012, 31. Yes. So you get this information also. So that is another parameter that you can give into the data dot history variable. And then now, oh, I forgot to mention, you can also give an interval over here. So interval is 1 month. So you will get a monthly, split. So during, I think it's June, sorry, it's May. So at May it was 23, 19, 17, so on, ended at $21. Now let's say you have a bunch of, stocks. Let's say stocks equal to, yeah. So you can store this in a variable stocks. Now you can say I have to download stocks. You can give the starting date as, let's say, 2019, just before COVID, and end date, let's say, just after COVID, around 2021 or 2022. Let's say 2021, 12, yeah. And yes, okay, sorry. Got to, yeah. So now you get every stock's opening and closing from this time period to this time period. You could have also specified, period. Let's see what we get. 1 816. Yeah. Um, right. So this is the Greenwich Standard Time and not the Indian Standard Time. So time in UK. 817. Okay, right. So 816. Right. So if you run it again, you will get the price right now. So this was just a brief about Y Finance and what it can do to assist you in your investing decisions. Y Finance offers a lot more of metrics, and you can always look at the Y Finance documentation. And here you get, a complete understanding of everything that it provides. So you can just go to the API reference And here you have subtopics, and under this you have a lot of metrics. So in case you're looking for some specific metric, you can go search it up here. Let's say we had used institutional holders. Let's say you want analyst price targets. You can just see here, you can see how to use it. You can just implement it here. So it says ticker.analyst underscore price underscore targets, and it is a type dictionary. It returns a type dictionary. So you can just go here, just showing an example of how to, you know, use the API reference. So this is how it is. So ticker is our stocks, you know, keyword. So data is our ticker, as you see in here. This MSFT data stores the MSFT ticker. Now let's go down. Data dot analyst price targets. Analyst price targets. Yes. So now you can just run this. You can see currently it's at 421.5. Analysts predict that the lowest is going to be the switch, the highest, the mean, and the median. So that's all for this video. Thanks for watching. Hello guys, welcome back to another video in the Finance with Python series. This is Anirudh here, and today we're going to look at a finance based time series analysis. So here I have, taken a bunch of stocks and commodities like gold, and I have, tried to do some time series analysis of it. So this is like a from scratch video which involves all the libraries that we had seen in the previous videos, like Pandas, NumPy, Matplotlib, Seaborn, and so on, Y Finance, so on and so forth. So let's get started with it. So here I've just imported, the necessary libraries like NumPy, Pandas, and so on. And we have, tried to take different stocks like you have the Apple, Microsoft, Intel, Amazon. This is Goldman Sachs. This is gold, and so on. So let me just run that real quick. And we just want to download data for like the last 5 years, which is from 2020 to 2025. Okay, so loading. Hmm. So now you can see what are all the columns that are present, in our variable data. So data is downloaded all these, stock data, right? Stock and commodity data over the period of 5 years. And you can see what all are, the column names. So you have the closing price for Apple and other stocks and commodities, the highs, lows, open volume, etc. So now let's, try to plot the closing stock price, as time progresses. So these are just basic matplotlib commands where you are just referencing the closing price of a particular stock. So here you're iterating through tickers, and tickers was defined here, which is a list. So this variable takes each and every element of the list, takes the closing price, and plots it here with the x-axis as date, right? So that's what we've done here. So you have the Apple stock, Microsoft, Intel, and so on and so forth. Okay, Intel has heavily dropped in the last 5 years. That's a very big drop, right? From $60, I suppose, to $23. Oh, 23, 24. Let's check Intel stock price. 21. Okay, and yeah, this is the same data. So it was around 60 and 21 right now. So this is exactly what we've plotted here. It's just that maybe, this is a bit more stretched out. Let's try to do that. So maybe I could adjust the, yeah, I think this is better, right? So I have just tried to increase, this x-axis length so that it resembles more like how it's shown in Google stock data, right? So now I think these two look pretty similar. Let's probably have a side-by-side comparison of it. Where is Intel? Intel. Okay. Yeah, it's just that it's a bit enlarged. We can fix that. Let's give this as maybe three. I think three should work. Yeah. Mm, yeah. More like, yeah. Now I think it looks much better. But I think this is the figure size they have used for, uh, doing it in Google. Whatever. This is what they have used here also. Right, so let's just move on. I just wanted to show you, how to change the dimensions and give like a figure size and all of that. So these are very basic stuff. We already covered this in, the tutorials. Now let's move on. So yeah, this is just data routing. Okay. Now here what we are trying to do is we just want to reference the closing price and the volume of the stock. So what the dot describe does is it gives you certain statistical measures for the variables that you have taken over here. So here we have taken close and volume, right? So it gives you the statistical measure like mean, standard deviation, the minimum, maximum, and the 25, 50, and 75 percentiles, and so on. The round off to just basically means that you're just rounding off to two decimals. Like you can see here, rounds off to two decimals. Similarly here, so on and so forth. Right. So we have tried to get some data about the closing price and the volume price and some statistical measures regarding that. Now, let's say if you want to selectively, get this minimum column, the mean, standard deviation, the median and max. You don't want the 25, 50, and 75th percentiles or the count. So you can selectively choose these rows alone by using the aggregate function. So what the aggregate function does is, um, you can give a variable here, like I've given data of close, and you can just combine these few rows, right? You can give these rows, you can combine them and make it into a new table. And that's what we can see here. Yeah, so you get these columns alone instead of all of these. So maybe you're just trying to make the amount of data that you're seeing more concise so that maybe you can understand something better from it rather than looking at all of this. Maybe if you look at something like this, maybe something might strike you, right? So here now we are trying to take the difference between two consecutive rows. So this is mainly to, check the difference between the closing prices or the change in the amount of volume that's being traded, right? So obviously the first column is filled with NANs because there is no previous row behind it, but values start coming from the second column. So this value is essentially got by subtracting the value here in the original data table minus the value here. And that is what this value is. That's what this reference is, right? So we have just given a dot difference function, takes the difference of consecutive rows, the values in the rows, and puts it over here. So here you can see that let's look at closing price of Apple, how it's varied. So it's varied by 0.28, then 0.38, then when negative, highly negative, again, so on and so forth. But see, maybe difference is more like I don't think it'll give you that much of information because the difference of a stock can be subjective. So let's say there's a stock for $100, it becomes $105. So that's $5 of difference, right? But that's not the same as $1,000 stock becoming $1,005 because the percentage change is much higher when $100 stock becomes $105. So that's what I've tried to do next. So instead of taking the difference alone, taking the percentage measure between the two consecutive values is much easier to. It's much more valuable. And then probably now that we have looked at percentage change, You can see that this is more intuitive to understand rather than dealing with actual values. You can look at the relative percentage change with respect to the initial value. So these are the initial values. Okay. Okay. Now here we are looking at the average daily returns of a particular stock commodity. So here we have taken the closing price and the percentage relative percentage change. We've tried to take the mean so that it's uniform across the whole time series of 5 years, and we have plotted the average daily percentage of daily returns that you can expect from the stock. That is what is given over here. Average is the mean percentage change or percentage returns, as I call it, of the stock price. That's what this means. Taken and plotted it. We can see that Intel has been consistently giving you negative returns. So this stock is probably good for shorting, right? Since it's giving you steady negative returns, I think traders should short the stock. Anyways, so these are some things that you can do. Maybe I should also add like a you know title. So I can say the title of this is going to be daily average percentage returns. I think this works. Yeah. Oh, what happened? Oh, I think I had to give it here. Daily average. I think now it should work. Yeah. See, what happened is, I had given the title before I had, plotted the bar. So what happened is it just ended up creating a new figure, right? A new figure. So yeah, that's what happened. So now we have the title over here. Now I think it looks pretty good. Maybe we can add, the X label and the Y label. Yeah, I think now it looks much, much better, much more informative, I would say. So yeah, let's move on. Now let's look at logarithmic returns. Okay. So why would anyone want to use logarithmic returns when here we have already looked at first initially we looked at the change or the difference without using percentages or without having anything relative to it. Then we looked at using a relative term so that it's sort of normalized, instead of having $5, $10, you can look at it as a relative percentage change. So I think that made more sense rather than just taking the difference, right? Now, what we're saying is let's probably look at the log of returns. Logarithmic returns are often preferred in financial analysis over simple percentage returns for several reasons. For several reasons. So these are some of the reasons. So let me just tell you about them, each one of them. So time additivity is the first one. So log returns can be added across time periods to get the total return over a long period of time, and this is not true for simple returns due to compounding. Yeah. So the main, if you look at the properties of how a log function works, this is pretty much self-explanatory, right? So you can add the log returns over a period of time to get the total return over a period of time. And okay, normality. We generally like normality because it tells you, you know, which percentage of return tends to be the maximum, which is in the middle of the normally distributed graph. So, and it's also visually appealing and it gives you more information. So we look like normally distributed graphs. So log returns tend to be normally distributed than simple returns, which is a desirable property for statistical modeling. This is the second reason. Third reason is, yeah, just like, since the graph is normally distributed, it's going to be symmetric, right? And log returns are symmetric around zero. So which is even better. So this is like a standard normal distribution, if you get what I'm saying. So let me just show you what a standard normal distribution looks like. The ocean. Yeah. So standard normal distribution is about centered about zero. So that's one of the best, advantages of using standard normal distribution. And when you want to do some statistical modeling on this data, the log return sort of gives you a good way to perform these calculations. So as you can see here, a 10% gain and a 10% loss have the same magnitude but opposite signs in log returns, unlike simple returns. Right. Yeah. So that was just a brief about why logarithmic returns should be used. So here, we're just trying to calculate the logarithmic returns. We've taken the data close of the current and the data dot close price of the previous day, dividing it, and then we get the returns. That's what we've done here. And now, what is this? Now we have, tried to take all these returns. So as I've add side here, you can add the log returns over a period of time to get, the total returns over a longer period, right? So that's what you've done here. We've tried to compound all these returns over a period of time, and we have just normalized it by, taking e to the power of log so that you get a value. Like use e to the power of log of x is just x. E, e power log 10 to the raise e is just 10. So you're just applying the exponentiation over here and plotting it. So here you can see the total returns. So it starts from 1 and either goes down or goes up. And this brown line is of Intel, right? So here we're just, we're taking the cumulative sum of all the logarithmic returns, and we are taking e to the power of the cumulative sum. So what it essentially does is you take the exponentiation of the cumulative returns, right? So then you get the simple term or the growth term, like you get this particular term out of it, since you're doing e power log of this term. So we had seen that the log of returns is just the current price versus the previous day price. Right, so that's what we've done here. And this is the example of time additivity, this property that we have seen here. So we've showcased that property. Now maybe, this looks a little messy, right? And maybe you want to look at something that's a bit more smoother. So what I've done is instead of taking a daily sort of frequency, we're taking a 1 month frequency. So the wherever the stock price is on that month's end, we are plotting that. So I think now it looks much, much more smoother, right? So that's what you've done here. So yeah, this just changes the frequency to a monthly time period. Label equal to right means that you see, since you can either take returns based on the first day of the month or the last day of the month, but here we've chosen to take the last day of the month, and dot last means we're just referencing it to the last value found in that particular month. Okay, so this is what it means, and then we are just plotting it, resampling. We had already seen this part. I'll just explain this part. and now we've plotted it. Now, probably let's now look at some statistical, you know, methods or calculations that are also done. So here, what we've tried to do is we are trying to take a window of 20 and then we are calculating the various measures. There are central measures of tendency like maximum, standard deviation, minimum, the mean, so on and so forth. So what this essentially does is we are taking the a 20-day difference, right, between the max, standard deviation, minimum, and mean. So that is what rolling of 20 means. We have run this. Now, so using this, we have created a new column in the data table called exponential weighted moving average or EWMA. So we have taken the closing prices of Apple and we have tried to calculate the exponential weighted moving average. And we have two parameters here. So the minimum period equal to 20 means that only after the first 20 periods, it will try to calculate the exponential weighted moving average. And half-life equal to zero point 0.5 is the sort of decay rate that is applied on these weights. So decay rate of half means it gets half after every day or every iteration. And if you give smaller values for half-life, it means that more amount of preference is given for current values rather than past values. So that is what exponential weighted moving average does. And now we have tried to plot like the mean, max, and exponential weighted moving average for the last 200 rows in the data. So, and we have also tried to differentiate all of these three measures using green, red, and blue dotted lines. And this is just the line width that you represented. Now you can see this beautiful graph over here with the legend, right? Now moving on, rolling statistics. Yeah, that is what I had shown you over here. Okay, where was it? Yeah, here, exactly. So yeah, as I was saying, rolling statistics is a major tool in the so-called technical analysis of stocks. It's compared to fundamental analysis, which focuses, for instance, on financial reports and strategic positions of the companies whose stock is being analyzed. That's what fundamental analysis does. A decade-old trading strategy based on technical analysis is using two simple moving averages. So in the previous video, I had showed you simple moving average, right, to plot the stock. So I taken, I think, simple moving average for a 50-day time period and a 252-day time period. So an exponential weighted moving average is much more, a useful and more advanced measure. And the idea is that the trader should go long on a stock or financial instrument in general when the SMA, shorter SMA, is above the longer SMA and go short when the opposite holds true. So yeah, here we have also tried to take the SMA, simple moving average. We've already taken the exponential weighted moving average, right? So we take simple moving average. Let's run it. So we have taken two SMAs. This is the short time period SMA and this is the longer time period SMA. So here it states that traders should go long on a stock and the shorter SMA is above the longer SMA. So if SMA 1 is greater than SMA 2, then he should go long on the stock. Agreed? And vice versa if the opposite holds true. Now let's try to plot this and check if we should go long or short the Apple stock. We have tried to plot this over here. I've given it like this using a new variable because we are referencing two variables here. So it becomes just a little complex to give this, inside the dot plot function. So I was thinking of making it simpler in this manner. So here, let's see. Whenever SMA1 is greater than SMA2, we go long. So everywhere you can see SMA1 is greater than SMA2, right? So we are going long, and you have seen that the stock price has always increased. Sorry. So it's useful to go long, right? So starting from here, the SMA2 is always lesser than SMA1. So it's useful to go long. But now when it dips, you can see that the SMA1 has dipped below the SMA2. And so it's okay to go short. So you can short it maybe at this position, exactly where SMA1 went lesser than SMA2. So that's around here, and sell it somewhere here. So you get this small profit. Yeah. And again, you can use this strategy and go long here when SMA1 outperforms SMA2, and then it's a full uphill. Yeah. So that's a strategy that many traders use. So now, yeah, since we had also tried to take a position, so we are also noting it down on the data frame. So we are having a new column called positions, and we're representing it as 1 if you want to go long and -1 if you want to go short. So let's go ahead with that. Okay, this is the same plot. I don't understand why secondary underscore y is not getting plotted. Okay, now I understand the problem. We needed positions inside this, right? We want to put that also inside this. So maybe let's try to update AAPL underscore data equal to, maybe let's try to copy this. This fully, and where is it here? Let's also give another positions data of positions. Yeah, perfect. Now I think it should work. I know we don't need this. Just it out. Now maybe let's try. Let's just try with the positions. Yeah, works. Okay, so that was just a bit of tweaking, and now we can look at what position we should take. So this is a much more interesting graph. So you can see where exactly to go long, where to sustain, and where to go short. So this red graph represents the. Okay, now it works. So I think the red graph now represents where exactly to go long, where exactly to go, short on the stock. This is a very, very useful graph to have. So you are sort of comparing the SMA1 and SMA2, and using the red position graph, you are trying to assess when to go long and when to go short. These are very, very powerful and useful stuff. Okay, now that we've seen this, let's go to correlation. Although there is not much correlation between all of these stocks, let's still look at the correlation. So let's just run this and show you what it means. So what is correlation? Correlation is this sort of measure that tells you how correlated to things are to each other. So we can take the correlation between it, the fact that will it rain today, given that it's cloudy. So it's these two are correlated, right? So if it's cloudy, there is a certainty that it will rain, and correlation gives you the sort of measure or the probability of it raining. I think that's how we can understand it. So here we have just used the SNS Seaborn library and used a heat map from it. So this is a heat map, which is a very visual representation of the different the correlation of different variables. So that's what I've done here. It's a very simple thing and very useful thing to see. This is something interesting. So gold and the SPY stock have a 0.84 correlation, very, very high. Similarly for Microsoft and SPY, Apple and SPY, very, very high correlations. So So the SPY, so the SPY or S&P 500 has a very big, huge correlation with the Apple stock and the Goldman Sachs stock and the Microsoft stock. So whenever the S&P 500 rises, it Apple rises, and you can see that when Apple rises, Microsoft rises, so on and so forth. A lot of correlation, a lot of interesting things to understand from this. Now let's try to compute the Sharpe ratio. So what is the Sharpe ratio? Sharpe ratio is this sort of measure that compares the return on an investment by taking the risk. So this is popularly used in risk analysis, and it gives you um, a measure of whether it's worth taking the risk or not. Let's look at that. So we can see that. So here, yeah, we can see the Sharpe ratios. Oh, returns. Happening here. Think, not sure what happened over here, but why does it show a lot of NANs? Oh yeah, we didn't take the NANs from returns dot drop NAN. No, in place equal to true. Yeah, now I think it should be fine. So you've dropped the all NANs from returns, and I think that's why it was showing NANs. Now maybe let's try once again. Yeah, GDX. Okay, returns. Why does GDX show NANs? GDX minus infinity. Oh, okay. That's the reason. So maybe let's try to remove this. This is all part of the data cleaning process, right? So sometimes, there'll be certain outliers like minus infinity. So we did not know this all along, even when we tried to visualize it, right? So I think here we are taking the log, and maybe there was log zero, I think, and that gave you infinity. So that's the problem, log zero. Log zero is undefined, or I think infinity. That's the reason it's minus infinity here. So maybe now let's try to remove this. Okay, now what we can do is okay. So now we have resolved this problem. So we have a minus infinity over here. So what I did is I just replaced the infinity and minus infinity values. So just in case there is an np dot infinity over here or a minus infinity over here, I'm just going to replace it with an nan value. So let's just say returns equal to returns of, now what I'm going to do is now returns will have an nan value instead of a minus infinity, right? So I can just say returns dot drop nan in place equal to true. Now I think this should work. Now let's look at returns. Uh, yes, we have the column is gone. Great. Now let's look at calculating the Sharpe ratio. Yeah, now it reflects for every other stock. So perfect. Stuff like this might happen. So, anyways, we managed to resolve that. So again, Sharpe ratio is a measure for, it gives you the measure of returns versus risk. You're taking the returns versus the risk-free rate that we are defining. And he's just taking the mean by the standard deviation of the excess returns, and this is what the Sharpe ratio is. And then we are just printing the Sharpe ratio for every stock. Now here, this is the last thing that we're going to see. Here we are trying to look at the volatility of the stock, or how much the stock price moves, right? So we have taken the rolling window to be 20 days, and volatility is just the standard deviation of, in those 20 days, how much the standard deviation of the closing price over a window of 20 days. And we've plotted the volatility. So this is the graph. Maybe we can just run it again. Yeah, so you can see the volatility of every stock and all of this. So this, and with this, our video is over. In this video, we had looked at, some rolling statistical methods, why it is important, or why you should use logarithmic returns. We had looked at some correlation matrix using the Seaborn library, and some data manipulation over here. So when problems like this occur, you see things like this very late. So the problem was, I think, when I took the logarithm over here, the log returns. Let me go over that. Let me just explain to you what happened. So when I took the log returns over here, I think just ended up being 0. So it just gave me a minus infinity, I think. And when we tried to, take the Sharpe ratio, then we came into this sort of problem. Or maybe it was because of something here. Maybe the standard deviation was negative 0. Or maybe that's one of the reasons why it became minus infinity. So there could be a variety of reasons somewhere in between. So that's maybe the reason. So we had looked at how to correct that. Great. And yeah, that's all for this video. And I hope you guys have now come to, sort of learn how to work with time series data, the different libraries that are used in this, how to do data handling manipulation, and how to graph the time series data. So this is what I had covered in this video. This is a fairly long video, and I advise you to take your time with it. Thanks for watching, and stay tuned for the upcoming videos. Thank you.
Hello guys, welcome back to another video in the Finance with Python series. This is Anirudh here, and today we're going to be looking at cross-section data manipulation. So in the previous videos, we had looked at, time series data, and today we're going to be looking at cross-sectional data. So let me just tell you the main differences between them. Okay. So time series analysis basically examines data from a single entity over multiple points in time. Whereas the specialty of cross-sectional data, cross-sectional analysis, is that it looks at the data from various entities, but at a single point of time. So in time series analysis, the entity is, let's say, constant, and in cross-sectional analysis, the time is constant. Okay, so I think that should clear your, I think that should give you an idea of what these two mean. And you have another thing called as panel data. So this is a study of how entities or variables change over time for individual entities. So you track the price, not price exactly, you track the variables change or entities change over time. And this can be for a bunch of variables. So for example, it can be like tracking the income change of a group of individuals across multiple years. So that is an example of panel data. And this is called as panel data. Yeah. So in panel data, neither the time is constant nor the variable is constant. Right. So today what we're going to do is we are just going to take a small example of financial data and try to do some cross-sectional data manipulation over it. Okay, as you can see here, we have taken data. We have taken small data that has different country names along with its GDP, population, inflation rate, unemployment rate, exports, etc. And what we're trying to do is we'll convert this into a data frame and do cross-sectional analysis on it. This is a cross-sectional example of cross-sectional data because the data is taken for a particular year. I think this is 2023 data. So Since the year is constant, this is called cross-sectional data, and it's doing info on it. Now, GDP per capita is like the best indicator for any company's, any country's growth, right? So what we're going to do is we're going to engineer GDP per capita by dividing GDP with the population. We'll also add a factor of 1,000 over here to, make this conversion possible. One is in million and another is in billions. So for that reason, we'll do this and round it off to two decimal places. Yeah. So we have the GDP per capita here for every country, sorted on the descending order. And let's try to plot this as well. So we're taking the country and the GDP per capita, giving a title, and then, we can plot this. So this is an example of, cross-sectional data handling or manipulation. I had covered, the other features or other things that you could do on such data in my previous videos. So you can go ahead and look into that. Okay, now let's go into the topic called correlation analysis. So what is correlation analysis? So in our data set, you have, a bunch of variables. So correlation analysis is like a statistical method that is used to measure the strength of linear relationship between any two variables and, assign a number. So it just calculates like the change of, let's say, GDP per capita according to population. So how are these two correlated? So when you do a correlation analysis, you can understand how the population of a country affects its GDP per capita. And if it's positive, it means that greater population, greater GDP per capita. If it's negative, it means that it has a negative correlation. So greater population, lesser GDP per capita, right? And if it's zero, there is no linear relationship. Okay, also correlation analysis can only capture linear relationships. So that is one thing to keep in mind. And this is specifically designed to only measure linear associations. So like if it's not a straight line, the correlation analysis won't give you proper results. So you have to keep that in mind while doing correlation analysis. Anyways, so like we are trying to do correlation analysis for this data set. And here we have taken the GDP of a country, population, inflation rate, unemployment rate, GDP capita, exports, everything. All columns except the country column. And let's look at the correlation. So here this is called as a heat map, and this has been generated using the Seaborn library. So the Seaborn library is very useful for generating very visually appealing indicators, and heat map is one of them. So it gives you a correlation analysis. So it gives you a correlation between different variables. So these are the variables. Okay. So when we look at this, we have to look at values that are typically near one. So those are values that indicate strong correlation, right? So right off the bat, we can see a 0.89 over here between GDP and exports, which essentially means that, more the exports the country has, more the GDP it has, right? That is very basic and easy to understand. And we also have a negative 0.63 of GDP and population. Okay. So for the data that we've taken only 10 countries. So for this data, it says that it has found out that countries that have more population are having lesser GDP per capita. That is an interesting correlation that we got. 0.56 unemployment rate and GDP per capita. Yeah, that is really easy to understand, right? More unemployment rate, lesser GDP per capita. So we can derive a lot of insights like this by using correlation analysis. Yeah, so moving on to the next topic, this is called as outlier detection. So generally, you can look at outliers in a data set by using the box and whisker plot. So this is an example of a box and whisker plot. So how can you measure outliers? We can generally take an interquartile range. Yeah, so we generally identify the quartiles in a data set. So we can take the first quartile, which is after 25% of the data, quartile 2, which is after 50%, and quartile 3, which is after 75% of the data. So what we essentially do is, let me just type it out here. So we calculate Q1 25th percentile, Q2 50th percentile, and Q3, which is at the 75th percentile. So we calculate all of this, right? What we do after this is we calculate something called an interquartile range, which is Q3 minus Q1. Okay, so this is the interquartile range, and after this we define the upper and lower boundaries for that particular data. So the lower boundary is like the you're defining the maximum amount of, let's say, the minimum value that you can accommodate in the data set, which you see as being right. And upper boundary is like the maximum amount of value that you can accommodate. So minimum and maximum values. So these are given by lower is Q1 minus 1.5 IQR. And the upper is given as Q3 plus 1.5 IQR. Yeah. So this is a summary of how an outlier detection is generally done. And we have generated the box and whisker plot over here. And look, we have gotten, three outliers, two in GDP and one in population. Yeah. Okay. So that was on how to calculate outliers in a data set. This is just another representation of the outliers. Let's run it again. Yeah. So now, when you're looking at GDP and everything, you want to look at the wealthiest states. So we are taking US, Germany, and Canada because all of these three have the maximum GDP per capita. And we just try to print these using a Phillips curve analysis. So the Phillips curve is basically a theory which states that inflation and unemployment have a stable and inverse relationship. So what it means is, with greater economic growth, there is greater inflation, which leads to more jobs and less unemployment, right? So that is what the Phillips theory means, and this is the Phillips curve analysis. Here we have just, plotted the GDP per capita along with inflation rate and unemployment rate. So here you can see this wonderful graph. And yeah, so this was just some basics about cross-sectional data, outlier detection, and correlation analysis. Thanks for watching and stay tuned for the next video.